I guess we'll try this again, and I'll try not to ramble so much uh, and keep the time down a little bit. So let's start by talking about the outer planets. The outer planets are Jupiter, Saturn, Uranus, and Neptune. And you have two gas giants, Jupiter and Saturn, and two ice giants, Uranus and Neptune. So start by talking about Jupiter. Jupiter is the biggest planet in our solar system. It is a little more than 5 times the distance from Earth on average, or distance from the Sun as Earth on average. Its orbit takes about almost 12 years, but its rotation period, you'll notice, is very quick. It's only 10 hours. Um, this has to do with the way that the core is, and at this much pressure, there's not an actual surface, but it is actually kind of this mix of both gas and liquid, which there's not really a big distinction between the two, so that allows it to move a lot quicker as it rotates. It is the biggest, as I mentioned. It is 88,848 miles in diameter, and it has a pretty decent amount of gravity, which may contribute to its size. It is 2.52 Gs, and it's pretty cold. As you noticed from Mars, being a lot colder than Earth, Jupiter even farther out has a maximum temperature of negative 162 degrees Fahrenheit and a minimum of negative 258. Another interesting point that has to do with its gravitational pull is the number of satellites that it has. It has 79 moons. So let's take a look at the inside of Jupiter. As I mentioned, it is this mix of liquid and gas that at these tremendous pressures, so if you see 5,000 bars, 1 bar is around the pressure, the atmospheric pressure of the surface of the Earth on average. So as you get down towards the core 620 miles, the pressure is over 5,000 bars. So tremendous amount of gravity coming here from it, and then you have this very dense core. Jupiter has a ring system. This is actually a picture of the rings taken by the Voyager probe as it passed. You can see it's not extremely visible like Saturn's, but it does have a ring system. And here's a breakdown of them. Some of the rings aren't necessarily visible in the same ways, in the same spectrum of light that we can see, but here you can actually see some of its moons are orbiting within the ring system. And speaking of the moons, here's a breakdown of the 79. Many of these might have been pulled from the asteroid belt, and as I'd mentioned, the Trojan asteroids actually orbit the sun in the same orbit as Jupiter, but within the Lagrangian points 4 and 5. So it is technically cleared, but possibly some of those were pulled into the orbit of Jupiter. Then there's Saturn, our other gas giant. Saturn's slightly smaller than Jupiter, and a little bit further away. It is about 10 times the distance from the sun as Earth, and its orbit takes 29.5 years. Again, you have that fast rotation period because it is a gas giant. It rotates every 10.65 hours on Earth. Gravity, however, is about the same as it is on Earth. But if you look at our temperatures, again, when you reach about 1 bar, or so close to atmospheric pressure on Earth, that is negative 218, but at 1/10 of a bar, it's negative 308. And Saturn has the most satellites of any planet in our solar system. It has 82. So the makeup is pretty similar to that of Jupiter. You have that hydrogen and helium atmosphere. You have kind of this metallic hydrogen. There some solid metal core. And then let's check out the ring system. This is the most prominent feature of Saturn. This is actually a picture from the Cassini space probe, taken as Saturn eclipsed the sun. So you get to see really the entire ring system, not just the ones that are mostly visible. So you can see that here. And then here's a breakdown of the different ring areas, the size, and some of the different gaps in the rings. And as I mentioned, 82 satellites for Saturn, Titan being the most famous. There's actually some interesting stuff going on with Titan. It is a possible location that scientists would like to examine to see if it has liquid water underneath the solid ice there. Also, it has a number of very spherical moons, but also these oddly shaped moons as well. Our first ice giant is Uranus, and so it's not quite as big as the gas giants, but it is big. It is 31,763 miles in diameter. It is about 20 astronomical units away from the sun at its aphelion, and it takes 84 years to orbit. Its rotation period, however, still very quick, like the gas giant, 17 hours, 14 minutes. The gravity is just slightly less than Earth, but here we have the coldest temperatures out of any planet, negative 323 degrees Fahrenheit at 1 bar, and at 0.1 bar we have negative 364. Uranus has 27 moons. Let's take a look at the inside structure here. You have the outer atmosphere, like a layer of clouds. Then you have the atmosphere itself made of hydrogen, helium, and methane. But the thing that separates it from the gas giants is this mantle made of ice. Water, ammonia, and methane ices comprise this mantle around a solid rock core. Uranus actually has a very interesting ring system as well. Here you can see some pictures taken of it, and here's the breakdown. And if you notice, the rings here do not go horizontal as most ring systems. They're actually vertical. And we'll look at this in a second here. The axis for Uranus is actually horizontal rather than vertical like all of the other planets. So rather than it spinning around a vertical axis, it more rolls along the equator as it orbits the sun. Now, this causes the rings to have a vertical orbit, and the moons as well will follow that equator in the orbit as it rotates. So if you see here, its axis is almost parallel to the orbit, the orbital plane of our solar system. Kind of sets it apart and makes it unique. Here are some of the moons in the ring system of Uranus. And again, notice that it's orbiting in this vertical manner rather than horizontal towards the sun. The last of our outer planets is Neptune. Neptune being more than 30 astronomical units, so more than 30 times the distance to the sun from than Earth. Its orbital period takes 165 years, but again, like the rotation of Uranus, it's a relatively short rotation period of 18 hours. Its diameter, again, not as big as our gas giants, but still very big, 30,775 miles. Its surface gravity is just slightly more than that of Earth, and still very cold temperatures, negative 330 at 1 bar and negative 360 at 0.1 bar. Neptune has 14 moons. So now, again, the makeup of Neptune is going to be very similar to that of Uranus. You have this outer cloud upper atmosphere. You have an atmosphere made of hydrogen, helium, and methane, and then this ice mantle over a rocky core. Let's check out Neptune's ring system. This is actually a picture, I believe, taken by one of the Voyagers possibly, but it's an overexposure to where you can actually see the ring system very well, and some of the different ring types and ring names that the systems have. Here are some of Neptune's moons and their orbits as opposed to the ring system. Triton being one of the outermost, but it's one of the more well-known moons. So these are the outer planets, the giant planets, the gas giants, and the ice giants.